Welcome everyone to the part 4 of data visualization. Let's see the agenda of today's lecture. We will learn about two types of plots. The first one is KDE plot. The second one is heat map. So first of all, we will see some theory and then we will do some practical work. So what is a KDE plot? A kernel density estimate plot is a method for visualizing the distribution of observations in a dataset, analogous to a histogram. KDE depicts the probability density at different values in a continuous variable. KDE plot function is used to plot the data against a single univariate variable and also for bivariate analysis. It represents the probability distribution of the data values as the area under the plotted curve. Now you might be thinking that when to use a KDE plot. Kernel density estimation is a technique for estimation of probability density function that is a must-have, enabling the user to better analyze the studied probability distribution than when using a traditional histogram. So let's do some practical work. First of all, I will open Jupyter Notebook. Now I will open the folder of data visualization. From here, I will create a new notebook. Let's rename Data Visualizations Part 4. All right. So first of all, I will use Markdown for libraries. Now I will import the essential libraries. Import numpy as np. Import pandas as pd. Import matplotlib.pyplot as plt. Import seaborn as SNS. Let's run it. Now I will use another markdown. Read CSV cars equals to pd.read CSV. The data is data.csv separated by comma values. Now, first of all, I will clean my dataset. Data cleaning. So I will drop all of the null values by saying cars.drop any cars.columns equals to. Now I will convert the name of columns into lowercase and then replace the spaces between column names with underscore. Cars.columns.str.lower.str.replace the spaces with an underscore. Now let's use cars.head to see our columns. As you can see that our data set is now fine and clean to make visualizations. So first of all, I will use a markdown KDE plot. In order to make a KDE plot, I will say sns.kde plot and make a KDE plot for year. And I will pass the parameter of color as green. Let's run it. Now here you can see the density curve. The values between 2000. Now here you can see the density curve. The values between 2012 and 2019 have the most density. Now let's suppose if you want to shade this area under the curve, then you will say sns.kde plot cars engine horsepower, and I will say the color equals to green, and then I will pass the parameter of shade as true. As you can see that the area under the curve is shaded, so it looks more beautiful. Now let's suppose you want to create a KDE plot for all of the rest of numerical variables. Then you can use a loop. But first of all, I will have to make a list of numerical columns. So I will say list cars.dtypes cars.dtypes not equals to object dot index. Now I will say for column n numerical column sns.kde plot and make KDE plot for cars column color equals to green, and I will pass the shade parameter as true and plot dot show. Let's run it. Now you can see the KDE plot for all of the other variables too. As you can see, the values between 2012 and 19 have the most density. In the column of engine horsepower, the value between 50 and 400 have the most density. In engine cylinders, the value between 2, 5, 7, and 8 have the most density. The density in the column of number of doors is highest with 4. And the highway MPG is highest between 10 to 50. The city MPG density is the highest between 10 to 30. The density of popularity is the highest between -500 and 2,500. The density of MSRP is the highest between 0.00 to 0.30. Now let's move forward. For instance, I want to do a bivariate analysis. Bivariate analysis using KDE plot. Now, first of all, I will say make a KDE plot between cars.city mpg and cars.highway mpg and take the color of green and pass the shade as true. Now, as you can see here, that if the city MPG is between 10 to 20, then the highway MPG is also between 10 to 30. Now let's move forward. For instance, I want to see the distribution of density curve between highway MPG and engine horsepower. Then I will say sns.kde plot cars dot engine horsepower and cars dot highway mpg, and I will pass the color of green and the shades as true. Let's run it. As you can see, if the engine horsepower is between 200 to 400, then the highway MPG is between 10 to 40. Now let's say I want to make a KD plot for cars dot engine horsepower and cars dot city MPG, and I will pass the color of green and shade equals to true. So if the engine horsepower is between 190 to 400, then the city MPG is likely to be between 18 and 30. Now I want to create a last KD plot for today's lecture. So I will say sns.kde plot and make the plot between engine horsepower and cars dot popularity, and I will pass the color as the same as above and shade equals to true. Let's run it. Now here you can see if the engine horsepower is between 170 and 310, then the popularity is most likely to be between 0 to 2000. Now let's go back to slides. Next we have heat map. A heat map is a graphical representation of data where the individual values contained in a matrix are represented as colors. It helps us visualize matrix-like data in the form of hot and cold spots. Seaborne heat maps tend to send clear messages about correlations, which is measure of strength of a linear relationship between two quantitative variables in data, and that's why they're used by data analysts and data scientists alike. So when to use a heat map? Because of their reliance on color to communicate values, heat maps are perhaps most commonly used to display the correlation between variables in a more generalized view. Now let's do some practical work. So I will use a markdown of heat maps, and then run it. So first of all, I will say plot.figure fig size equals to 13 by 7, and then I will say sns dot heat map. So you just have to use the keyword of heat map to make a heat map. I will say cars dot correlation by saying CORR. Then I will say CMAP equals to greens. So CMAP is actually passing the color for the heat map. I will run it. So here you can see some boxes are light in color and some are very dark. and the values are between -1 to 1. So the boxes with dark color shows that these variables have a positive or a strong correlation, just like engine horsepower and MSRP has a good correlation. However, highway MPG and MSRP has a low correlation. Now let's suppose you want to generate a heat map with the values inside the boxes. Then you will say plot.figure fig size equals to 13/7 and SNH dot heat map as cars.core and CMap equals to range. So I will say here a not equals to true. So a not is just like annotation. And I will say plot.xtakes, which are these variable names. So I will rotate them with -45 degree. So I will say rotation equals to -45. Now let's see. As you can see that the variable names are now rotated so that we can read them more easily. And the values are between -1 to 1, and the boxes with dark green color shows a positive correlation. So if the values are close to 0, then it means those variable does not have a good correlation, such as popularity. However, if the values are near to -1, then it means they have a bad or negative correlation, such as highway MPG and city MPG. But if the values are close to 1, then it means they have a positive correlation, such as engine HP and engine cylinders. Now let's go back to slides. So this is the end of today's lecture. We have learned how to create heat maps and how to make KDE plots that shows the density distribution curve. So let's have a look at your homework. This is the link of the dataset, and these are your few tasks. Do some exploratory data analysis, use KDE plot, then use heat map, and find out which variables are strongly correlated. Now good luck, see you next time.